Okay, so this is today's topic, MOF based sensors. MOF stands for metal organic framework. So it is a three-dimensional structure with metals acting as nodes, metal ions. And they are connected by organic links. So these are the metal nodes. Zero ions, and these are the organic bridges. मतलब इसको लाइगैंड से so these sort of structures form इसको बोलते हैं metal organic framework. This is used for sensing because it has some properties. For example, it is porous in nature. It is permanent. And when I say porous, you can classify porosity as macroporous, mesoporous, or microporous. Macroporous means the porosity is greater than 50 nanometers diameter. Mesoporous means it is 50 to 2 nanometers. And microporous means it is less than 2 nanometers. So, metal organic framework MOFs we come into the category of having a mesoporous or microporous structure. So this is the first reason. Secondly, they have got very large surface area. Specific surface area, that is around 1000 to 6000 meters square per gram. This is the second reason. One is porosity, second is large surface area, और जो third reason है नंबर 3 is जो metal nodes हैं और organic ligands involves in organic ligands. They are first of all ligand effective. They are chemically they get induced, they get affected by chemically by photons or by electrical impulses. So there is a chemical influence, there is an optic influence, and also biological influence. So these are the reasons why metal organic frameworks are used. So I'll just recap through. So today's topic is metal organic frameworks, MOF, based sensors. Metal organic, it is consisting of metal nodes as ions and organic bridges, ligands. So CD, it is actually a crystalline, porous crystalline structure. Porous crystalline is probably scaffold fluid. So these structures have got porosity and they have got very large surface area, and the composition is active, chemically active. Secondly, they are like they can trap or accommodate the analyze मतलब जिसका हम लोग सेंसिंग कर रहे हैं, the one that is getting sensed, उसको हम लोग बोलते हैं एनालाइज. तो मेटल ऑर्गेनिक सेंसर्स का बहुत जगह भी इस्तेमाल होता है. फर्स्ट ऑफ ऑल तुम लोगों ने वो जो ब्रेथ एनालिसिस अल्कोहल जो ट्रैफिक पुलिस यूज़ करता है ना, ब्रेथ एनालिसिस उसमें यूज़ होता है. देन इट कैन बी यूज्ड इन गैस लीकेज. ठीक है. एक्सप्लोसिव्स डिटेक्ट करने में यूज होता है. इट कैन बी यूज्ड इन डिटेक्टिंग गैस सेंसर्स with gas लीकेज होगा. environmental sensors जैसे अमोनिया, VOC, volatile organic compounds, H2S, and biosensors, DNA, pathogen, glucose. There are different types of sensing used. Now let us come to the mechanism. How do they sense? Mechanism, there are basically 4 or 5 ways by which the MOF can sense. First of all is absorption. Right. Second is impedance. change. So there is something called FL quenching. There is something called QCM, or if not, photo induction. Okay. So these are the different ways. Okay. Let's start with another absorption. Absorption basically is used for gas sensing. Gas sensing में absorption use होता है. So, like variable volatile organic compounds, NH3, and all the different gases. So what this MOF do, as the gas is absorbed, there is a change in dielectric constant. There is a change in dielectric constant or dielectric constant. So there is a change in current. जैसे absorb हो जाता है gas in the middle organic framework, change in dielectric constant, and there is a change in current. So from that they can sense which type of gas is there. Impedance भी वही है. There can be change in resistance delta Z, or there can be change in current, or there can be change in voltage. Interesting is this one. Fluorescence quenching. This is basically luminescence. Luminescence based sensing. Luminescence, it's a phenomena where there is emission of light but prior to that energy has been absorbed. Anything or any process which leads to an absorption of energy followed by emission of light comes in the category of luminescence. So there can be basically three categories of luminescence. First of all is photoluminescence, electroluminescence, or chemiluminescence. Photoelectrochemical. So if the light, if the energy absorption has taken place with the help of absorption of photons, we call it as a photoluminescence. If it has taken place by absorption of electrons, we call it as electroluminescence. And if it has been due to some chemical reaction, then we call it as a chemical luminescence. Now photoluminescence is also, I've got two different categories that you can do. One is called fluorescence, FL. Another one is called phosphorescence, PH. इन दोनों में हल्का सा डिफरेंस है. Have you studied fluorescence, phosphorescence? Quantum mechanics में I think इसका मतलब क्या है? 2s plus 1 इसका एक नाम है, S is the total spin quantum number, singlet and triplet, ठीक है। If S is equal to 1, then 2s plus 1 is equal to कितना? 3. It corresponds to a triplet state. And if S is equal to 0, then 2s plus 1 is 1. This is called the ये वाला स्टेप कब होगा? S is equal to, it is actually S1 plus S2. If this one is, they are having opposite spins, then S is equal to 0. But if they are having, they have 3, if one, you are asking it there. Then S is equal to 1 by 2 plus S is equal to 1 by 2. स्पेक्ट्रोस्कोपिक टर्म्स को इस तरह से रिप्रेजेंट किया जाता है 2s plus 1 Lj का इन ऊपर कैंसलेशन इश्यूज। There is a triplet state and there is a singlet state, and molecules energy of molecule, molecular energy बेसिकली 3 चीज़ों से बनता है। इलेक्ट्रॉनिक एनर्जी, वाइब्रेशनल एनर्जी एंड रोटेशनल एनर्जी। एक सिंपल मॉलिक्यूल अगर हम ले लें ए एंड बी, तो ये जो मॉलिक्यूल है ये क्या कर सकता है? इट कैन रोटेट, इट कैन वाइब्रेट, इट कैन डू इलेक्ट्रॉनिक ट्रांजिशंस, एंड दीज 3 आर इंडिपेंडेंट ऑफ ईच अदर। Electronic energy is much higher than vibrational energy, and this is much higher than vibrational energy. जो independent of each other है, this is also known as von Oppenheimer approximation. Von Oppenheimer approximation. So इसको अगर हम in terms of energy and distance देंगे तो अपने पास हम इसको ऐसे रिप्रेजेंट कर सकते हैं, ठीक है। जब एनर्जी वाइब्रेट करता है तो ये वाला जैसे मैंने कल डिस्कस किया था, दिस इज हाउ द एनर्जी वर्सेस डिस्टेंस शेप टेक्स प्लेस। दिस इज ग्राउंड स्टेट एनर्जी लेवल, और इसको मैं बोलता हूँ एक एक्सैक्ट स्टेट डैश, ठीक है। और हर एक इलेक्ट्रॉनिक एनर्जी लेवल्स में देयर आर सम वाइब्रेशनल स्टेट्स। So this is Eg, that vector Eg's, this Eg is equal to V is equal to 0, this is called V is equal to 1, यहाँ पर कैसे वाइब्रेशनल स्टेट्स, और इन वाइब्रेशनल स्टेट्स के बीच रोटेशनल स्टेट्स, ठीक है। सो नाउ यू कैन अंडरस्टैंड कि कौन सा इलेक्ट्रॉनिक है, कौन सा वाइब्रेशनल है, कौन सा रोटेशनल। तो फ्लूरोसेंस में क्या होता है कि सपोज यू हैव अ मॉलिक्यूल इन द ग्राउंड स्टेट, और इसमें If there is absorption of light, right? Absorption of light, okay, क्या हो गया? ये excited state बना, bounded excited state. Now, if it comes back to the ground state without any vibrational change, we will call it as a fluorescence. The ground state, excited state, lambda absorbed block और नीचे के लिए fluorescence 10 to the power minus 8 seconds may just come down. So this is corresponds to fluorescence. Now in this process के बीच, if there is some internal reaction taking place, so that it goes to an in-between state. So this is a singlet state. If, however, the molecule, due to some reason, comes back and comes to this state, where the transmission gets delayed. Then we call it as a fluorescence. Fluorescence light जो होता है ना, रात को जो glows, that is because of this delayed transmission, because this is a triplet state. After some vibration states में, it comes back below the vibration states. V is equal to 0, V is equal to 1. ये जो states यहाँ पे mention किया है, वही states में it comes back and then it comes. So there is a delayed transmission, and this is called phosphorescence. Now, what happens in the case of an MOF is there is fluorescence quenching. Fluorescence quenching का मतलब है the intensity of the output intensity goes down. Why it goes down? Because the energetic, there is some reason is there is deactivation of energetic excited states. There is a deactivation of energy excited states. Okay, so there is a fluorescence quenching. Quench, जैसे तुम लोगों ने iron carbon diagram में होता है ना, suddenly the temperature. This is also a sort of quenching where there is a deactivation. The intensity of the output goes down. So this is how you can the metal organic framework can work. Now, similarly, there can be a photoinduction, some chemical reaction taking place. So the metal nodes or the organic ligands, it can get activated due to some chemical reaction or due to some photonic inclusion, and they can react differently. So to be redox reaction also. This is called quartz crystal modulator. Quartz crystal modulator works on the basis of change in frequency, F. The frequency of oscillation, it is inversely proportional to so if there is a quartz is being coated with a metal organic, this is the quartz crystal model. If it gets coated, इसको हमने कोट किया गया है MOF. तो क्वार्ट्ज की एक नेचुरल फ्रीक्वेंसी है, natural frequency of the quartz. Now, since MOF is able to absorb the analyte, so as it absorbs the analyte, अब जो absorb हो गया है, there is a change in mass, increase in mass, M goes up. As M goes up, so since F is proportional to 1 by M, so the F goes down. The frequency of the quartz crystal modulator goes down. So this is how you can detect what happened in this crystal. Okay? So एक बार just we can recap some of the from there. Today's topic is metal organic framework based sensors, MOF. Metal organic framework. Metal organic framework मतलब it is a 3D structure which is porous as well as crystalline, and it is formed by two components. One is your metal nodes, and they are connected by organic bridges integration. So एक solid 3D structure form होता है जो कि porous है, okay, and it also acts as a scaffold like a sponge. Sponge की तरह काम करता है जो where it can trap the molecules to be fitted, right? So that is called porous, basically mesoporous or microporous, and then for the very large surface area. These are the two things. Secondly, the composition, the metal loads and the organic ligands, they get affected by the following factors. They get affected chemically, they get affected by photons, optical, they get affected by electrical influence and biological influence. And they are used in different type of sensors, for example, biosensors, depth analysis sensors, also wearable sensors, sweat analysis technique, gas leaks, explosives, pH, ions, lot of them. इनमें इसका इस्तेमाल होता है. तो what is the mechanism by which they do it? You can do it by the following 5 mechanisms. First of all, absorption. When a gas is absorbed, there is a change in the dielectric constant. And dielectric constant is change, there is a change in the output. Absorption. Second is there is a change in impedance taking place. Either there is a change in current or voltage. There is a fluorescence quenching. This is fluorescence quenching. यूज हो सकता है। एंड अच्छा यहाँ पे अपार्ट फ्रॉम फ्लोरेसेंस क्वेंचिंग दूसरा एक चीज़ पॉसिबल है, दैट इज आइदर इट कैन अंडरगो समथिंग कॉल्ड रेड शिफ्ट और blue shift. I will explain what these red shift and blue shift means. उसके बाद there can be a photo-induced change and there can be a frequency change. So by these mechanisms they act as different sensor. So I will now discuss some important MOF based sensors जो कि बहुत recently discovered हुए हैं. हाँ ठीक. So recent studies. इसमें से first one is called ZIF8. Second one is called UIO66 and the third one is called MIL101. ठीक है. So all the basics about the MOF sensors जो डिस्कस कर रहे हैं. ZIF का मतलब है zeolite zolate framework. Zeolite यूनिक ज़ालोट फ्रेमवर्क. अच्छा ये जो नंबर 8 है इसका कोई टेक्निकल सिग्निफिकेंस नहीं है. ये जो ग्रुप है जिस ग्रुप ने सेंसर निकाला है उनका 8 कंपाउंड है. दैट्स व्हाई इट्स कॉल्ड 8. सो zeolite मीन्स zeolite मतलब SiO4 and AlO4. इसका टेट्राहेड्रल नेटवर्क को ये बोलते हैं zeolite. अच्छा imidazolate is an organic compound. It is C3H3N2-. तो इसका स्ट्रक्चर कुछ इस तरीके से है. N C डबल बॉन्ड C and Z. So this gives you energy. So this is how it looks like. So इसका जो खासियत है, it is hydrophobic in nature. And it is chemically, mechanically and thermally stable. And it is used in basically gases. So this is one of the ZIF8. अच्छा, जो सेकंड वाला है UIO, UIO मतलब इट्स यूनिवर्सिटी ऑफ ऑस्लो, गैस सेंसिंग में फैक्ट्रीज में यूज होता है, गैस लीक्स, गैस लीकेज, breath sensing, and also sometimes catalysis में यूज होता है. Catalysis में इसलिए यूज होता है because the trapping is good. You can trap the molecules at specific sites. Even already discussed here. Yeah. Okay. Biosensors, gas leakage, explosive, ये वाला explosive use नहीं होगा. Overall gas sensors में ZIF का इस्तेमाल. Second वाला जो this is the first one, ZIF8. Second वाला UIO6 means University of Oslo, Norway. It is based upon geometric clusters होते हैं, ZR plus 4 या फिर Hafnium plus 4. और इसका जो मेटल ऑर्गेनिक फ्रेमवर्क होता है उसको बोलते हैं कार्बोक्सिलेट. कार्बोक्सिलिक एसिड से RCOO-, ठीक है, RCO-. तो इसका अगर देखो तो बेसिकली so it is used in determination of ammonia in NH3, gas sensing में it is used for that. Again 66 मतलब इस research group का 66 compound, and same is this one MIL1. MIL का मतलब है MIL101 materials institute, Lavoisier, France. Institute में ये वाला metal organic framework है discuss. So you have basically chromium Cr+3 या Fe+3 या फिर aluminium +3 यूज होता है. Again these are the metal loads, और जो organic part है that is again carboxylate. This is the organic part. तो बेसिकली ये फूड डिटेक्शन में फूड स्पॉइलेज इसमें इस्तेमाल होता है. फूड तीनों नहीं MOF सेंसर्स का एडवांटेज यही है. MOF based sensors, they have the advantage of they can capture gas, okay, they can detect the gas, and they can transduce. You know this. Transduce मतलब to put it in some readable format. तीनों चीज एक साथ होता है. This is the advantage of these MOF sensors. Because some of the materials by which they are made, they are itself light emitters. जैसे कि lanthanide, lanthanides में there are some lanthanide जैसे यूरोपियन ER+3 और दूसरा है टर्बियम Pb+3. They are used as the metal nodes. ठीक है, तो इनमें खुद लाइट इमिटिंग प्रॉपर्टीज होती है. कौन सी लाइट इमिटिंग प्रॉपर्टीज होती है? ये वाला जो टेरेबियम जो यूरोपियम है, दैट इमिट्स लाइट 650 nanometers. That is the red. ठीक है, और जो टेरेबियम है दैट कैन इमिट लाइट 545 nanometers. That is green. MOF can also be used in MOF field effect transistors. MOF FETs. इसका एडवांटेज है कि अल्ट्रा लो लोड ट्रिलियन PBPM ऐसा कुछ ट्रिलियन, अल्ट्रा लो अच्छा. अनदर थिंग मैं डिस्कस करना चाह रहा था, दैट इज रेड शिफ्ट एंड ब्लू शिफ्ट. फ्लोरेसेंस क्वेंचिंग में एक जो टेक्निक होता है FL क्वेंचिंग, मतलब इंटेंसिटी ऑफ लाइट इज गेटिंग रिड्यूस्ड, राइट? सो देयर कैन बी एन FL क्वेंचिंग, देयर कैन बी एन FL enhancement, दोनों हो सकते हैं. ठीक है, इंटेंसिटी ऑफ लाइट का वेवलेंथ के साथ रिलेशन क्या है? इंटेंसिटी ऑफ लाइट का वेवलेंथ के साथ डायरेक्टली प्रोपोर्शनल है कि इनडायरेक्टली प्रोपोर्शनल है? आई थिंक कितना कुछ पावर होगा, पावर सम पावर ऑफ n मॉलिक्यूल. सो इफ फ्लोरेसेंस में इफ देयर इज अ फ्लोरेसेंस क्वेंचिंग और देयर इज अ फ्लोरेसेंस एनहांसमेंट, इन बोथ दिस केसेस मतलब देयर इज अ लाइट चेंज, देयर इज अ वेवलेंथ चेंज. सो इफ द वेवलेंथ absorption जिस वेवलेंथ से हो रहा है और इसको lambda absorption, so basically it is absorbing some light and it is emitting some light. So let's consider the wavelength with which it is absorbing is lambda A and the wavelength which is emitting is emission. Okay. So if lambda emission is more than lambda absorption, okay, देन क्या हुआ, क्वेंचिंग हुआ कि एनहांसमेंट हुआ? इंटेंसिटी क्या होगा? Intensity will going down, right? But if lambda emission is less than lambda absorption, there is enhancement of intensity. तो ये जो फर्स्ट वाला जो केस है, बिग जीरो, राइट? लोग ग्रीन को रेफरेंस मान के चलते हैं. So if there is an increase in wavelength, so it is moving towards red light, and if there is a decrease in wavelength, it is moving towards green light. So the increase in wavelength is called a redshift. Whereas a decrease in wavelength is called a blue shift. Increase in wavelength. So either it can be an increase in wavelength. एक characterization of materials जो तुम्हारा subject है, वहाँ पे तुम लोग जब optical analysis करोगे, तो वहाँ पे एक absorption UV vis और भी इंस्ट्रूमेंटेशन आया, UV vis characterization. So basically what it does is absorption versus the wave number. UV vis absorption. तो वहाँ पर भी you will study blue shift and red shift. Wave number on my line, because this is energy. All the spectroscopy जितने भी outputs हैं, they are basically in terms of wave number. Raman हो गया, तुम्हारे FTIR हो गया, और एक last one is there are MOF based composites. Graphene, CNT, all of the MOF-based composites are being developed to get better response. Now there are some limitations of this environment. पहला लिमिटेशन है कि इट इज मेनली डाइलेक्ट्रिक इन नेचर, है ना. सो इट इज नॉट कंडक्टिव. द मेन थिंग इज कंडक्टिविटी हम लोग इनपुट करते हैं, लेकिन बेसिकली इट्स डाइलेक्ट्रिक इन नेचर. सो दैट इज समटाइम्स हैपनिंग. सेकेंड इज स्केलेबिलिटी एंड लार्ज स्केल प्रोडक्शन. इंडस्ट्रियल पर्पस में बहुत ज़्यादा प्रोडक्शन या फिर स्केलिंग, देयर इज अ प्रॉब्लम इन इट. सेकेंडली सिलेक्टिविटी में थोड़ा प्रॉब्लम है, बिकॉज देयर माइट बी सम इंटरफेयरिंग गैस which may give false signal. Limitations थे और एक लिमिटेशन था स्केलेबिलिटी, मतलब स्केलिंग अप प्रोडक्शन, आइदर पुटिंग इट डाउन और पुटिंग इट अप. जैसे मुझे अगर मेम्स डिवाइस बनाना है, माइक्रो इलेक्ट्रोमैकेनिकल सिस्टम्स, then I need to scale down But if you like to increase the number of production, then you need to scale up. Scalability, size, related to size and number. अच्छा, दूसरा है स्टेबिलिटी. Sometimes the humidity factor and other environmental factor because they hamper the performance of these reactions. ठीक है, so